I told you I'd be back, and I told you something. V1Tech makes it easy to create your dream setup with a wide range of customizable PC parts, desk and wall art, gaming mats, custom phone cases, and more. Choose from existing designs or create your own to bring your favorite art to life, allowing you to truly make your setup your own. And V1Tech is proud to announce their all-new RGB Shadow Box wall frames featuring addressable RGB lighting and swappable artwork, allowing you to change the look and feel of your setup quickly and easily with no tools necessary. Start creating your dream setup with V1Tech by following the links in the description below. The power supply has supplied itself in our studio. This is a 60 volt, 5 amp power supply. In fact, I've accidentally already popped and killed something. So for the sake of science today, I told you we're gonna blow up some fans. But now we're gonna see exactly how much abuse they can really take. I'll be honest, I thought the 15 volts of our other one was going to be enough. We were so wrong, because even a 20 volt battery was not enough to kill a 12 volt fan. Yes, we had 2 of those. We could have wired them in series and had 40 volts, but then they would have probably instant popped. In fact, I know they would, because this one died at 30. And we would not have gotten the data to say how much abuse can the motor type really take before it completely obliterates itself. So with that said, let's get started. I've got another camera here so you guys can see on here, pointing at the screen that will switch back and forth. And the only reason for that is because I want the device facing me so that I can see it better. Obviously. And I want you guys to be able to see the dial and stuff too. So if there's any data we took away from the previous video, it's the fact that the amp rating printed on the back is not the amps that's pulled at 12 volts. So at 12 volts, 0.37 amps on here, we didn't see that. We saw, in fact, I'm gonna turn it on right now. Let's see. So it's set to 12 volts right now. It says it's rated 0.37. It's only pulling 0.13. So realistically, it could take nearly 3 times the amount of current to pop, at least what the motor's rated to, before anything bad would happen. But remember, if we slow it down and we make it go under load, give it some resistance, you can see that goes up, right? Because the motor's trying to force itself through there. We know 15 volts isn't going to break it. Oh, and by the way, we have a halon extinguisher on hand. It's gonna be a lot better than dry powder in this room if we need it for some reason. We are on a wood table, so
yeah, wood famously known for its fire fighting properties.
Yeah, you know, actually, before we murder the Cooler Master one, we should re-murder a box cooler. So as you can see here, this one is not going to do anything. In fact, when it sees 12 volts, nothing's going to happen. 0 amps, and I love having this fine dial. Look at that, the fine dial. So 0 because we probably separated the motor from itself. Like the coil probably broke, and that's why it's no longer completing a circuit. The coil probably snapped. The wires and the winding around that motor are so thin, it probably snapped. Anyway, so maybe we'll recreate what happened. So what I didn't do, I did not test what, there we go, so that's on now, right? I did not test what the voltage was at when I turned it on. I just plugged it in and turned it on. It was set out of the box to 30. So maybe before I pop it, we just go ahead and start to amp this one up. Do the amp draw. Oh. Okay. There's a bell curve here in the amps, and you guys can see it right here. As I exceed like 15 amps, so right now at 12 volts, right? So here's 12. It is pulling 0.097 amps. As I went up to about 15 amps, it went up to like, I don't know, it was like 0.15 or something like that. And then I approached 20 and then dropped back down to 100. So I'm not sure. Maybe electrical engineers in the chat can tell me why that bell curve is there. So is that where we're gonna start seeing failure happen? I don't know, let's see. So we'll go back to, see there's right around 15 volts. That's where we saw the most, it looked like. So there's 121, 123, 122, 121. So as we go up now, you see the amps are dropping. Now we're at 118, I'm at 17.6 volts. At 18 volts, we're at 114. 19 volts, we're at 0.109. We're reaching a point though where we're not getting any more RPM out of the fan, and that's probably apparent by that amp draw. So how far up can we go? Oh, dude, it's slowing down. We're at 21 volts, and now it's at 0.94 amps. It's slowing down. The motor is dying. Oh, there it goes. Oh, so it's got a shut off. I don't know what the amp rating is on this, but it has a shut off. Watch this. If I hit 21 volts, it shuts off. It's 20. It's 21. It's 22. That's 22.5 volts right there, and it has slowed down significantly. 22.3 speeds it back up like that. So what if you just crank it? So about 28 amps, or 28 amps, well, 28 volts right there, it just said goodbye. You can smell it.
Did it?
You can. Oh yeah, there's the magic smoke, hold on.
Whoa!
Remember, this one's that 1.37 is what it was rated at. Oh, the longer it sits there, the more the amps start to drop a little bit. 223, 222. It was at 225, then 222. 221. It's like the motor's slowly dying right now. So here is like forced degradation, right? So let's go up a little bit higher. 220. 22 volts, 22.2, 22.5, 23 volts. Oh, wow, that one slowed down and popped at the same time, whereas at least the AMD one like took more abuse.
Oh, I can smell from here.
I put my nose right in it. That is not a smell you ever want to hear, or you don't want to hear smells. If you hear smells, I can hear smells. This smell has brought back so many bad memories of like me blowing up speaker amps and stuff on accident in cars. All right, the 2 volts here. Let's move on to, okay, so that took the most voltage right now at what, about 25 volts. Here's the little basic Antec like F12 fan. This fan just sucks, okay? Like in terms of its capabilities, it barely moves any air when free floating. Like it is not a good fan, okay? I'm just saying. So, like it takes 23 volts, 23.4 volts, nearly double its rated voltage to make it even catch up to some of the other fans that are on this table. Ironically, it's taking more abuse than anything so far. Okay, so far this little crappy fan might be just like, it's like the whole Japanese gentleman's agreement. It's not 280 horsepower, it's 315, you know? Okay, 30 volts. There's 30 on the dot. Yeah, 30 volts, 0.248. What's funny is the volts are going up, but the amps are not really climbing anymore. Doesn't say on this one what its actual rating is. It has it's almost smells like it's getting hot. Oh yeah, 56C. There's 37 volts. We are more than 3 times its rated voltage. 44. Okay, it turned off at 44, but it's still pulling amps, but it's not turning the blades. So now it's probably just gonna be getting hot for no reason at all. 77, 78.
See smoke.
Okay. It's at 81C. 82? This is at 12 volts now. I'm at 12.42 volts. So now it's clearly got a short because temps are just continuing to climb. There's 90C. Yeah, it's like we got a soft death because the coil is intact, but something is clearly wrong in there because it's not, like I just want to crank the knob and I don't want it to go into freaking fire. Like I'm cranking the knob. Oh, I see the smoke now. Okay, turning it off. This is the one that could lead to a fire.
Yeah.
Look at that. Oh, now it popped. It took that much to pop the coil. Now it's at 61 volts and 0 amps, right? Woo! Yeah, it's 100C right, 101C right there. Got a photo for you. Probably shouldn't have left it on.
Now check the temperature.
It's a firecracker. 103. That scared them.
I know. Did you see any fire at all?
I thought I saw a flash, but that could have been my life before my eyes. 106C.
Oh my God.
Well, that shows what an idiot I am because I just assumed like, oh, there's 0 amps, the coil popped, there's no more current going through, like it broke. But clearly it was still absorbing somewhere. Something literally popped, exploded, as you can see.
Is that the inside of a capacitor that exploded?
Possibly? Oh yeah, that's probably, oh yeah, because there's another one right there. We literally claymored it. I hate this one because I'd have to hold it. All right, here's what we're gonna do. Oh, I saw the spark on that one. Did you see it?
No.
Oh, damn it, it was a big old spark. It shot out. Wait, okay. Can't decide between performance or noise optimization for your next PC case? Then Be Quiet has you covered with their new Darkbase Pro 901. The interchangeable top and front cover allow you to choose either maximum airflow or virtually inaudible operation. Fan brackets with integrated hubs and pogo connectors make cable management easier than it's ever been, while a touch-sensitive front I/O panel provides state-of-the-art operation. To see the full list of specs of the Be Quiet Darkbase Pro 901, see our full breakdown video at the link in the description below. Dude, those Be Quiet Silent Wings Pro 4s are like the closest thing to Delta fans. Dude, the amount of air.
Jesus.
Oh, okay. That was the softest little. Oh God, it was at 5 amps. I just looked over, I was like, wait, why does it say 5,000 something?
Dead short then.
Yeah, because even when I turned the voltage down, it was at 5 amps. So, and that's the limiter, 1 amp at 1.4 volts. So that's dangerous. We will not continue playing with that one. This one could literally pop into a flame.
Yeah.
Delta fan time. This is scary, even though it has the guards, okay? Because things could still potentially fit down in there. It's slowing down at 20. See, at 18, it's loudest. Watch, there's 17, 18, 19, 20. It slows down. Dude, the amount of air coming out of this thing.
I know, I can barely hear you.
Oh my goodness. Something happens when I go like that. What you'll notice on camera, when I go things happen. And every now and then a baby pops out. Not of me. I'm just curious as to what happens, and maybe this is where someone in the chat that's an expert at this can tell me why just hitting it real hard instantaneously causes the amperage to, like in this case, the motor doesn't even smell like anything. Nick, we must mark this one now as bad. I don't understand.
Pretty much every fan on this table is.
Except these two, they lived. I don't understand why hitting it with sudden voltage like that causes the amps to skyrocket, but the motor still worked. So maybe, like Phil said, partial dead short, but I'm wondering exactly what might have happened in there. And that's where you experts get to tell me what an idiot I am and how easy this is, if I had a brain.
Also, what other stuff should we apply 60 volts to?
Give me your nipples, Phil.
God!